start with surds and indices. Surds are the numbers which cannot be further written into more simplified versions. For example, under root 2, under root 5, the things which are written in under root. Indices is the powers. I write something x raised to the power y, 5 raised to the power 2. This is called as indices, where this number is called as a base and this is called as the power. We call it power, index, exponent of this base. So this is your indices. Under root 2, under root 3, these are the surds, but under root 4 and under root 16 are not surds, because under root 4 is 2, under root 16 is 4. Clear? This can be simplified and this can be written as 2 and 4. So these two are not surds, whereas under root 2 and under root 3 can be written like this, but this is your non-terminating decimal expansion. So these two are surds. Clear? Now a raised to the power n, this is called as indices, where you have the base, you have the power or the exponent. Then we have the types of surds, pure surds. Pure surd means I am writing only like this. Under root 2, under root 3, only an irrational number. Root 2, root 3. These are the examples of pure surds. Mixed surd, where a rational and irrational are written together. For example, 3 root 5. Irrational and rational, they are written together. Compound surds, 5 plus under root 3. This is your compound surd, where you are adding or doing any multiplication or with this surds. Then you have the binomial surd, where two factors, like if I write under root 15 times under root 3, what do you get? Under root 45. So this kind of expansion where two surds give rise to one surd, and this is called as binomial surds. Coming towards the following laws of surds, these are very important while doing the simplification questions or while solving the techniques. Like under root a times under root a. Many a times you see a question under root 5 whole square. What does it mean? And you always do this, under root is cancelled with the square and you have the answer 5. This is what it is. And your answer is going to be a. Under root a ka whole square and you will get a. Clear? Now under root a times under root b. A and b, irrational times irrational, your answer is going to be under root ab. For example, under root 5 times under root 3. You will do 5 times 3. 15. Put it into one under root. Clear? Now, under root a times under root a. What is it? A. And what is left is m. So you are going to multiply it. For example, 5 root 2 times root 2. Root 2 times root 2 is 2, and multiply it with 5, you will get the answer 10. Clear? Again, in the next question, a and a. These both are under root. Your answer will come a, and this m times m. M, n, a. The product of these three. Next. Now this is under root a, this is under root b. But we have learned under root a times under root b is you multiply them. So just do under root ab and multiply it with m. Clear? For example, like this could be the example, or instead of this you have under root 3. So you multiply all these three terms, write 5 aside and do under root 6. Clear? Now come to the division. Under root a upon under root b. What you can do is under root a, what you can do is a upon b and give the whole under root. Clear? These are the same things we do in the laws of indices as well. Wherever the exponent is same, just divide it and give them the same exponent. Here what we are doing, we are dividing it and giving them the combined under root. Clear? Under root a divided by under root a. It both cancels and you will get the answer 1. M root a plus n root a. Now there is a concept called as like and unlike. Like is where you have the same under root. Root 2, root 2. Be it 5 root 2, 3 root 2, the under root value is same. So these are the like. Unlike is 5 root 3, 3 root 2, they are different. So this is your unlike. Like can be added, can be subtracted. Unlike remains same. M root A, N root A. Like or unlike? Like. So M plus N and under root A. Add these two and write it only once. Or you can understand it, we are taking root A common. If I take root A common, I am left with M plus N. Here no change. Why? This remains same because it is unlike. I cannot simplify root 2 plus root 3. I have to put in the values and then add. You cannot say root 2 plus root 3 is under root 5. No. Clear? But root 2 times root 3 is under root 6. Clear? Next. M root A times N root A. This is your like surds. So your answer is going to be M minus N under root A. And for this unlike, so this remains same. There is no change. Clear? Then coming towards the concept of simplification, what all we do in simplification is we do the prime factorization. For example, this is root 8. 8 can be written as 2 times 4, 4, 2 times 2, and this is 1. So I can write 8 as 2 times 2 times 2. What we are doing now is we are doing the square root. That means there is a small 2 outside. This 2 means make pair. This is 2 times 2. Write it outside and write it only once. This has no pair now. Let it be inside the under root. So this is your simplification. Again, 2 times 2 times 2. This is the prime factorization. We are doing the square root. So I am going to take this 2 times 2 outside and write it only once. Make a pair, bring it outside. No pair, keep it inside. Clear? This makes a pair, bring it outside. There is no pair of it, keep it inside. Under root 12. 12 can be written 2, 6. 2 times 2 times 3. That means 2 comes out and 3 remains. This forms a pair, comes outside, no pair, keep it inside. Under root 45. Now 45 can be written as 15 times 3. 15 can be written as 3 times 5. So the prime factorization becomes 3 times 5. 3 comes outside. So your answer is 3 root 5. This is how you simplify. This is how simplification works. Now this is your like. Okay. So I am just going to deal with the front numbers and my under root 2 remains same. 4 plus 5, 9, 9 minus 7 is 2. So my answer is 2 root 2. Now this is A minus B whole square. A minus B whole square. A square plus B square minus 2AB. So I'll do it 3 square plus 4 root 3 whole square minus 2 times 3 times 4 root 3. Just deal it like a separate number and you can use the identities. 9 plus, now 4 root 3 whole square. What does it mean? I have written 4 under root 3 whole square. This square is with 4 and this square is with root 3. Clear? 4 4s are 16 and you will do 16 times 3. Minus 3 times 2 is 6. Okay, 6 times 4 is 24 under root 3. You can simplify it and you will get the answer. 5 under root 3 times 13 under root 5. You can do this times this. 5 times 13 and then multiply these two. Under root 15. You can also simplify it, that 15 can be written as 3 times 5 and no, there is no need. This is going to be your final answer. Now coming towards the conjugate. What is the meaning of conjugate? Conjugate means its mirror image. That I am mirroring it. Conjugate of root A is root A. A root B is root B. If the conjugate of A plus root B, conjugate is going to be A minus root B. Wherever you have the plus, conjugate is minus. You have the minus, conjugate is plus. This is what I have written here. Clear? What is the conjugate of root 6 minus root 5? Conjugate is root 6 plus root 5. Conjugate of root 3 plus 4 root 3, root 3 minus 4 root 3. Conjugate of under root 5, conjugate of 5 root 3, only root 3. Clear? This is going to help you while doing a topic, what we call it as rationalization. Rationalization works where we have the under root in the denominator. For example, I am solving a question and I get 5 root 3. Now this under root in the denominator should not be there. To remove this under root, we do the rationalization. What is the target of rationalization? So that this denominator becomes under root free and numerator can have the under root. How to do the rationalization? We multiply and divide. What do we do? Multiply and divide with what? With its conjugate. This is why we learn the conjugate. What's the conjugate of this? Do it under root 5 times under root 5. You get this. There is no under root in the denominator. So this is correct. This is rationalization. Multiply it with root 11 upon root 11. On the top you get 3 root 11 and at the bottom you get 11. No under root at the denominator. So this is rationalization. Multiplying it with root 3 over root 3. 3 root 6 upon 3. 3 and 3 cancel. Under root 6. Clear? Now let's do this question. I am going to multiply and divide with its conjugate. Multiplying it 2 minus under root 3 and 2 minus under root 3. Clear? Now multiplying it individually, 1 multiplied by 2 minus root 3 plus root 3 multiplied by 2 minus root 3. Division. A plus B, A minus B. So I am going to write A square minus B square. 2 square minus root 3 whole square. This, solving it above, you get 2 minus root 3 plus 2 root 3 minus 3. I have just opened the brackets. Divided by 2 square is 4, root 3 square is 3. Now 2 minus 3 is minus 1 on the top, and solving this you will get 2 under root 3 remains as it is. What is minus 1 plus 2? 1. And at the bottom you have 1. So your answer is root 3 minus 1. I hope the concept is clear. Thank you.